Okay, everybody, since I'm not going to be able to finish this PowerPoint with you, and because we need to go on into 6.1 and 6.2 next time, I'm going to go ahead and finish this with you online through video so that you get the benefit of me talking you through this. Now, this was the one that I made a little mistake on this one today. It says, what is the probability of 252 or more? Okay, so we're looking at the probability of 252 or more wins. And when I did that on my binomial CDF, I did from 0 to 252. I should have done to 251. This is what my board should have looked like. Okay, so here is my whiteboard. The probability of 252 or higher out of 460 tosses is 1 minus the probability of 251 or lower. And I put a 252 right here. And so when I did my 1 minus my binomial CDF, over here on the right, I had a 252 right there. And I should have had a 251. And when I do that, I get 1 minus. Okay, so let me show you on the calculator how we're figuring this out. We're going to go to second and down here to the distribute button. See the DISTR onto the top. And then I'm going to scan down with my down arrow until I get to binomial CDF. The CDF is the cumulative one. Okay, so then I'm going to enter that. Try to do things with one hand and hold the video here. So remember, the first number is going to be the total, which in our little thingy says it's 460. So we're going to put 460 in here. And then a comma. And then the 0.5, because remember we're flipping a coin and it has a 0.5 probability of the coin toss. And then we're going to put, instead of 252, we're going to put 251. And since this is cumulative CDF, it's going to get the probability of everything from 0 tosses all the way to 251 tosses. And when I hit enter, I get 0.9775. So now, remember, I'm doing 1 minus that because this is not the one I want. I want from 252 up instead of 251 down, which is what I have calculated on my screen. So now I'm going to type in a 1 minus second answer, which is going to give me my 1 minus 0.9775, and I get 0.0224, which is what they had. And I had gotten something different because I had put in a 252 instead of a 251. My bad. So 0.0224. Okay, so back here we had the probability 0.0224, which you just saw me get on the calculator. And it is low because it is less than that 5% that we were saying was our cutoff mark. This shows that it is unlikely that we would get it by chance. Okay, so we're going to say it's significant. And that, and if you look at the very first part of this chapter, it's saying we are left with the more reasonable explanation that the team winning the overtime coin toss has a better chance of winning the game. So basically, if you go read that little chapter problem at the beginning of chapter 5, you'll understand what that means there. But we've basically done everything we need to do with that, so I'm not going to belabor that little example any further. Okay, so then we're going to move to StatDisk as a way to analyze. And when you're using StatDisk, you're going to go to Analysis. Okay, so here I've opened up my StatDisk, and I'm going to come up here to the top, and I'm going to get my cursor on Analysis. Okay, so here I am on Analysis. I'm going to come down below Analysis and get probability distributions, and then go down here to binomial distributions, and I'm going to click it. Okay, so then I get this cool little screen, number of trials, and we're going to do the 460 trials that we just finished doing. Okay, so we're going to do 460, and we're going to do the success probability, remember, was 0.5 on this one, 0.5, and then we're going to evaluate. And then we get this cool chart, automatic. So now, look at what happens. I'm also given my mean, my standard deviation, my variance right now, and now I can go all the way down here. And remember, our number was 252. Okay, so 252. Now on the stat disk, I can look at the 252 and look across there. We've got the probability of exactly 252 is pretty small. Okay. The probability of 252 or fewer, which is not the one we want. And here is the probability of 252 or greater, which is the one that we needed. So StatDisk is really cool if you have it, because it gives you everything immediately that you could possibly want. And here is the, where'd my PowerPoint go? Okay, so here on the PowerPoint is the same thing done on your PowerPoint, and you're seeing the highlighted 252 there on the PowerPoint. So now we move to the next slide, and we're talking about doing the same thing, but we're going to go use the Appendix A table here to find the binomial by hand, and this time we're going to use a different situation because our table does not go up to 460. Our table only goes up to n is equal to 8, and so we're very limited. So notice it says that we can only use the table when the technology is not available. That's the only time we would want to do it. The table A1 lists binomial probabilities for select values of the n and the p, but it only goes up to n is equal to 8. So anything greater than 8, and we can't do it using the table. So we're going to go look at the table and do another problem. So here is a problem that we're going to do with the table. Based on a Harris poll, 60% of adults believe in the devil. Assuming that we randomly select 5 adults, use table A1 to find the following: the probability that exactly 3 of the 5 adults believe in the devil, the probability that the number of adults who believe in the devil is at least 2. So we have 2 different situations here. We're going to do 3 of 5 and then at least 2 from the table. So if you look in your book on 683, you will see this cool table, Table Appendix A and Table A1. Okay, so that's where you should be on page 683. And notice that on the left here are my n's. N is 1, is 2, 3, 4, 5, all the way to 8, and guess what? It stops right there. And so look under 2, it's got 2, and then on the X, so think of the flipping 2 coins, okay? You could have had 0 head, 1 head, 2 head. That's the most you could go. So then the table goes to 3. And if you have 3 coins, you're going to have 0 heads, 1 head, 2 head, or 3 heads. Those are all of your options. So remember, your X column is listing all the different outcomes you could have. So if we had 8, we have 0 through 8 are all the different options that we can have, and then we're done. Okay, so looking at our problem, we have 60% of the adults believe in the devil. So we're going to call believing in the devil our success. And so our probability of success is 0.6. And then the probability that exactly 3 of the 5 adults believe in the devil. So our n is the number that we're of trials, and our n is 5. And then we're talking about exactly 3 of the 5. So we're going to go back to our table here, and here's 5. And under 5, we're going to look at the 3. Okay? And then notice that across the top are the probabilities P all the way across. And there's 13 of them, I think is what they said. There's 13 different probabilities. If you happen to have a probability that is not listed, you can't use the table. So our probability here is 60. So we're going to come to the 60 column, 60%, and we're going to come down, and then we're going to go over here to the 5 and look under the 3, and we're going to go all the way across to the 60 column. Okay, so down here is the 60 column. All right, and then going across, I'm trying to do it. You should be doing it in your book because I'm trying to video and do this at the same time. I'm getting 0.346 when I go across to the 3 that is underneath the 5, and then I go across. 0.346 is the one that's underneath the 60%. I don't know how well you can see that, but 0.346 is the probability of exactly 3 of the 5 adults believing in the devil. Okay, so on the next slide, they put it a little bit more clearly. You can see the 60% here on this slide, and then they're showing the 5, and they're showing the 3, and they're going across there to 0.346. And then they're saying right here, the probability of 3 is 0.346. The probability that exactly 3 of the 5 believe in the devil. Okay, so now what we're going to do is the second part. The probability that the number of adults who believe in the devil is at least 2. Okay, now at least 2 would be the probability that it's exactly 2, plus the probability that it's 3, plus the probability that it's 4, plus the probability that it's 5. So basically, we're going to have to find the probability of 2 and 3 and 4 and 5 and add all of those together to get the probability of at least 2. So here we look and we've got 0.230, 0.346, 0.259, 0.078, and we add up all of those right here on the next slide. So basically they're taking all of these that we just mentioned, they're adding them together, and they say you've got a 91% chance that at least 2 people out of 5 believe in the devil. I think that's very interesting. Okay, so now let's use our calculator on this same problem based on a Harris poll, 60%, blah, blah, blah. Okay, so the A portion is, it says using the technology to do the B portion. Now I'm going to do both of them because I really want you to get very handy with using your calculator. So on the first one, I'm going to set up just a binomial PDF. The binomial PDF is what we want to use when we just want one value, the probability of exactly 3 out of 5. So I'm going to show you that one first. Okay, so notice I've put this on my calculator, binomial PDF for one probability, and that's out of 5 people, 60% chance of success. 3 people is what we're looking for, 0.3456. And remember on the PowerPoint, probability of 3 was 0.346. They've rounded the 0.3456 to 0.346 as they should. And now we're going to do the second portion using our calculator. So on this one we used the table, and we got 0.913 for the probability at least 2 will believe in the devil. Okay, so here, going back to the B portion here, we're looking for the probability of 2 or 3 or 4 or 5 all added together. This is also the probability of 0 and 1 from 1. So 1 minus the probability of 0 plus the probability of 1 is going to give us the probability of all the others, which is 2, 3, 4, 5. That's one way to do it. And it's also 1 minus the binomial cumulative, CDF, 5, 0.6, and 1. So the cumulative up to 1 would give me the 0 and the 1 added together. And then I take that value, so 1 minus this is going to give me this right here, which is the 0.913 that you see on the previous slide there. Okay, so I want you to get really comfortable with doing this and think of complements when it helps you do less calculation. Okay, it's much faster to calculate the CDF, everything before 1, and then subtract it from 1 to get the 2, 3, 4, 5 than it is to do them each individually. Okay, so now it says find the binomial probability using the table. So now we've got n as 8, so we're going to go to 8 on the table, probability 0.10 or 0.1, and x is 4. Okay, so it says what is the probability that exactly 4 of them carpool? Because we're using exactly, we're going to use the PDF. Okay, so this one is the table. So the PDF we're doing on the calculator. Sorry about that. This is the table. So we're going to go to the 0.10 column and follow it down. We're going to go across under 8 and 4 across there. And we got 0.005 is the probability that exactly 4 of the 8 workers carpool to work. All right, so now we're talking about using the formula for the probability. So instead of the calculator, let's use the formula this time. A survey indicates that 41% of the women in the U.S. consider reading their favorite leisure time activity. You randomly select 4 U.S. women and ask them if reading is their favorite leisure time activity. Find the probability that at least 2 of them respond yes. So we've got our N as our number of trials is 4 because we're choosing 4 women. 0.41 is our probability. And our Q is the 1 minus the 0.41. So remember our Q is 1 minus the P. We're looking for at least 2 or more, which means the probability of 2 plus the probability of 3 plus the probability of 4. Okay, and when we do the formula here, go to the next slide, we've got, remember our formula is, since we're doing 4 things, n is 4, the combination of 4 things, take it 2 at a time, and then the probability of a success, and since it's probability of 2, we're going to square that, and then we're going to have over here 2 plus 2 is 4, so the other number is 2. In other words, n minus 2 is 2. So the failure gets a 2. And then we do all of that math and we get 0.35. Then we do the same thing with probability of 3, probability of 4. We add them all up together. And the probability of 2, 3, 4 put together is 0.542. Okay. We could also say that this is 1 minus the probability that it's less than 2, which would be 1 minus the probability of 0 and 1, and that would have worked also. Okay, so this one says 60% of the households in the U.S. own a video game console. You randomly select 6 households and ask each if they own a video game console. Construct a probability distribution for the random variable x. So now we want to construct the whole thing, 0, 1, 2, 3, 4, 5, 6. Okay, so here we have 6, and then 0.6 is our probability of success, and 0.4 is our probability of failure. So here we've got 0, 1, 2, 3, 4, 5, 6. And again, how do they get 0.004? They get it from the formula. You've got to plug the 1 into the formula and the 2 into the formula and so forth until you get all of them. And remember that all of these together should add to 1. And here is the probability histogram that goes with that one there, okay, which you should be familiar with already. All right, so now we did not get to talk about these. The mean is the n times the p. So remember, P is the probability of success and N is the number of trials. So I multiply N times P and I get the mean. I multiply N times P times Q and I get the variance squared. And then I take the square root of that and I get the standard deviation. Very easy formulas for a binomial distribution. Completely different from what we have had before and very easy to calculate. Okay, so here we have an example. Find the mean, variance, and the standard deviation. In Pittsburgh, Pennsylvania, about 56% of the days in the year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. So we're calling 56%, the number of cloudy days is our success, okay? So we're going to say our P is 0.56, our Q is going to be 0.44 because that's the complement of the 0.56, right? 1 minus 0.56 is the 0.44. And so our mean is the N times the P, which is the 30 times the 0.56, which is 16.8. We would expect to have an average of 16.8 cloudy days. Okay, and then the variance is NPQ, which is the N times the P times the Q, which is 7.4. And then the standard deviation is the square root of that, which is 2.7. Okay, so the standard deviation, remember, is going to help you find out if something is usual or unusual, and whether it's insignificant or significant. So I could say, would it be unusual for me to have 24 cloudy days? Okay, so what would I do? I would take my mean, and then my mean is 16.8. I would take my standard deviation and multiply it by 2, and I'd get 5.4. I'd add 5.4 to 16.8, and I would not get up to 24. So yes, 24 days would be unusual because of our significant rule there. Okay, so on the average, there are 16.8 cloudy days during the month of June. The standard deviation is about 2.7 days. Values that are more than 2 standard deviations from the mean would be considered unusual. Okay, so here they're showing you what would that value be. 16.8 is the mean minus twice 2.7, the standard deviation, would give you 11.4. If you had fewer than 11.4 cloudy days, that would be unusual. Okay, if we had more than 22.4, remember my number was 24, okay, a June with 23 cloudy days would be unusual. So I had picked 24, and it is above the 22.2. So you're analyzing for significance here. And there once again is your significantly low, significantly high values, and values that are not significant are the ones that are in between. So here we have another example, okay? A previous example involved N is 460 overtime wins in NFL football games. We get P is 0.5 and Q is 0.5 by assuming that winning the overtime coin toss does not provide an advantage. So both teams have the same 0.5 chance of winning the game in overtime. So they're using the 0.5 here as equal chances because they're assuming that they don't have any kind of an advantage from winning the coin toss. All right, find the mean and the standard deviation for the number of wins in groups of 460 games. Use the range rule of thumb to find the values separating the numbers of wins that are significantly low or high. Is the result of 252 overtime wins in 460 games significantly high? Okay, so when we do that, we go with our N is 460, our P is 0.5, our Q is 0.5. Previous formulas can be applied, so we've got our NP is our mean, and there we have 460 times 0.5 is 230 games. So our average would be 230 games that we should expect to be won. And then our sigma, our standard deviation, is 10.7. For random groups of 460 overtime games, the mean number of wins is 230 and the standard deviation is 10.7. So now when I go to my rule for significance here, I take the 230 minus twice the 10.7 and the 230 plus the twice the 10.7. And anything in between 208.6 games and 251.4 games would be considered usual, but we were doing 252 games, which is past that and therefore unusual. Okay, so we're going to say it is significantly high numbers of wins because it's greater than 251.4 games and not in between the two. So it says the result of 252 wins is significantly high because it is greater than that extreme value there. So here again, significantly high, significantly low. We can do this with probabilities, 0.05, 0.05. We saw this same slide on our probability distribution PowerPoint. So this is nothing new to you. Okay, now this one here is just the formula and why the formula is the way that it is. And that is pretty much the end of 5.2. Here is your homework on 5.2. 5 problems. Have fun. And I will have these ready for you next time so that you can see them worked out in detail. I hope that helped you. Me finishing through with talking through the rest of the PowerPoint. And so we will start 6.1 and 6.2 next class. We will not come back to 5.2 because I finished explaining it on the videos. Okay, so I'm going to send you a message telling you to listen to the videos. And this is Mrs. A, and may God bless your day.